In this video, we will look at section 9.2, which discusses the topic of sum and difference identities. The idea, let me set it up a little bit. So suppose you were asked what is sine of 30 degrees plus 60 degrees. So we are adding two angles. One might be tempted to say that this is, you can distribute it and think of it as sine 30 plus sine 60. Well, let's see if that is actually the case. Is it or is it not equal to it? First, sine of 30 plus 60 is basically sine of 90 degrees. And we know that that's equal to 1. Whereas sine of 30 degrees is 1/2. Sine of 60 degrees is √3/2. When you add them, what you get is 1 plus √3/2, and not 1, which would be the case if this equation was true. So clearly, you cannot distribute the trig function like that. So then the question is, how does one think about sine of 30 plus 60? How does one simplify it? So there are 6 trigonometric identities which tell us how to work with sums and also differences of angles. The first identity is if you have a cosine of a sum of two angles, alpha and beta. Cosine of alpha plus beta is equal to cosine alpha cosine beta minus sine alpha sine beta. Similarly, if you have a difference of cosines, a cosine of a difference of angles, then this is cosine alpha cosine beta plus sine alpha sine beta. The sine of a sum of two angles, alpha and beta, is equal to sine of alpha times cosine of beta plus cosine of alpha and sine of beta. A difference, alpha minus beta, and the sine of that is sine alpha cosine beta minus cosine alpha sine beta. Tangent of alpha plus beta is equal to tan alpha plus tan beta over 1 minus tan alpha tan beta. And then the last one is a tangent of a difference of two angles. It's tan alpha minus tan beta over 1 plus tan alpha tan beta. So let's see what kinds of things we can do with these identities. Let's say you were interested in knowing what sine of 105 degrees is. Now, you cannot find the exact value of sine of 105 using the techniques we have looked at so far. 105 is not one of our special angles. Its reference angle, which is 75, is also not one of the special angles. So at this point, we can't figure out what the exact value is. However, if you think of 105 as made up of 60 and 45, then we can use the sum identity for the sine function. So sine 60 cosine 45 plus cosine 45 cosine 60 sine 45. So in those identities that I wrote down, we are thinking of, we're using this one. And we are thinking of alpha as 60 and beta as 45. And then both 60 and 45 are our special angles. We know their exact values, so we can plug them in. Sine 60 is √3/2. Cosine 45 is √2/2. Cosine 60 is 1/2. Sine 45 is √2/2. So this is √3 times √2 is √6/4 plus √2/4. So this adds up to √6 plus √2/4. So that's the exact value of sine 105 degrees. You can do the same thing with if angles are in radians. So in problem 4, we are asked to find the exact value of cosine of 7 pi over 12. Now, 7 pi over 12, it actually turns out to be 105 degrees. If you do if you do 7 pi over 12 times 180 over pi, then the pi's cancel out, and 12 times 15 is 180, and 7 times 15 is 105. And like in the previous example I gave, we split this into 60 and 45. So if you're working in radians, you would do 7 pi over 12 equals pi over 3 plus pi over 4. 60 degrees and 45 degrees. And then we use the sum identity for the cosine, thinking of pi over 3 as alpha and pi over 4 as beta. So this becomes cosine pi over 3 cosine pi over 4 minus sine pi over 3 sine pi over 4. And then we plug in the values. So that's 1/2 √2/2, √3/2, and √2/2. That's √2/4 minus √6/4, or √2 minus √6/4. So that's cosine of 7π/12. Let's take another example. This is problem number 8. Tan of -π/12. So we have to find the exact value of this. First of all, since tan is an odd function, we can pull the negative out, and that's tan of π/12. And π/12, if you convert it to degrees, that's 15 degrees. And you can think of 15 as being 45 minus 30. So basically in radians, π/4 minus π/6. So that's what we are working with, negative tan π/4 minus π/6. And then we use the difference identity for tangent, and this is thinking of π/4 as alpha and π/6 as beta. So this becomes negative tan π/4 minus tan 6 over 1 plus tan π/4 tan π/6. And then we plug in the numbers. So tan π/4 is 1. Tan π/6 is √3/3. And then 1 plus, again, 1 times √3/3. So this is 1 minus √3/3 divided by 1 plus √3/3. And then you can cancel the 3's. So it's basically right. So when you combine them using a common denominator of 3, the first numerator would become 3 minus √3. Same thing in the denominator, 3 plus √3/3. So you cancel the 3's, and this becomes 3 minus √3/3 plus √3. And then we can rationalize it by multiplying the top and the bottom by the conjugate of the denominator. The conjugate of 3 plus √3 is 3 minus √3. So you keep the same terms, just flip the sign in between. So you multiply the top by the same thing. And this is the standard way of rationalizing when you have a binomial or 2 terms in the denominator instead of 1. So we go ahead and multiply stuff. 3 minus √3 times 3 minus √3 is when you FOIL it, or it's the square of 3 minus √3. So it simplifies to 9 minus 6 √3 plus 3. And in the denominator, you have 3 square minus √3 square. So 9 and 3 is 12 minus 6 root 3. And here you have 9 minus 3, which is 6. Oh, and there's a negative sign in the front. So that's negative 12 minus 6 root 3 over 6. And then if you divide top and bottom by 6, this becomes negative 2 minus root 3. Or you can distribute the negative sign, and that's root 3 minus 2. So that's the exact value of tan of negative pi over 12. In problem 10, we have to figure out the exact value of this expression, sine of x plus 11 pi over 6. So it's a sum of two angles, and we have the sine function. So we will break it up using the sum identity for sine. So sine x cosine 11 pi over 6 plus cosine x sine 11 pi over 6. Now, 11 pi over 6 is, if you trisect the quadrants and count to 11, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So you basically end up here. So 11 pi over 6, you can think of it as just negative pi over 6, because if you went clockwise, this angle would be negative pi over 6. So I can write this as sine x cosine of negative pi over 6 plus cosine x sine negative pi over 6. Now, notice that I'm trying to avoid using the unit circle here. So there are other ways of doing this if you don't have the unit circle handy. Then we use the fact that cosine is an even function, sine is an odd function. So this becomes sine x times cosine of pi over 6, since we can drop the negative sign. And the second term becomes negative cosine x sine pi over 6. Cosine pi over 6 is root 3 over 2 sine x sine pi over 6 is 1/2. So that is our answer. Let's look at problem number 18. Where we're doing just the opposite of what we did in the previous problem. So we're given the expression sine 2x cosine 5x minus sine 5x cosine 2x. And we have to shrink it into a single term. So notice that this has the form of the right side of our identity for the sum of two angles, this one. Sine alpha cosine beta plus cosine alpha sine beta. So if you think of 2x as alpha and 5x as beta, then it's basically the right side of that identity. And the left side, I think I misspoke. There's a minus sign in between, so it's not that, but the one below it. It's a difference identity. So the left side is sine alpha minus beta. So this would be sine of alpha is 2x, beta is 5x. So that's sine of negative 3x. And again, sine being an odd function, you can bring that negative outside. So sine 2x cosine 5x minus sine 5x cosine 2x is simply negative sine 3x. Let's look at number 20. In this problem, we are given that the sine of an angle A is 2/3, and that it's a second quadrant angle. And then we are also given that the cosine of another angle B is negative 1/4, and that's a second quadrant angle as well. And using this information, we have to figure out sine of A plus B. And cosine of A minus B. Now, we know that sine A plus B is sine A cosine B plus cosine A sine B. Similarly, cosine of A minus B is cosine A cosine B plus sine A sine B. So in order to know what sine of A plus B is, we need to know four things: what sine A is, what cosine B is, what cosine A is, and what sine B is. Of those four, we are given two. So we basically have to figure out, using the value of sine A, we have to figure out what cosine A is. And using the value of cosine B, we can figure out what sine B is. So that will be our strategy. And using the identity that cosine of A is plus or minus square root of 1 minus sine square A, we can see that since sine A is 2/3, sine square A is 4/9. Moreover, A is a second quadrant angle where the cosine function is negative. So we keep the negative sign, discard the positive. 1 minus 4/9 using a common denominator of 9 is 5/9. Then you can take the square root of 9 and bring it outside. So cosine A is negative root 5/3. Similarly, using cosine B, we can figure out sine B. It's again the second quadrant angle, and in the second quadrant, the sine function is positive, so we keep the positive sign, discard the negative. Cosine B is negative 1/4, so the square of that is 1/16. And that is 15/16, or square root of 15/4. So that's sine B. Once we know these two, we can go back to our identities to figure out the answer. So sine A plus B, plugging in the numbers we found here, is sine A, that's 2/3 given to us, times cosine B, which is negative 1/4, again given to us, plus cosine A, which we found was negative root 5/3, times sine B, which we found to be square root of 15/4. And then you can simplify this. So negative 2/12 minus root 5 times root 15 is root 75/12. I can pull the negative sign out and then combine the two terms. And think of root 75 as root 25 times 3. And you can take the square root of 25 and bring it outside. So this is negative 2 plus 5/3/2. So that is what sine of A plus B is. Similarly, we can find cosine of A minus B. Which is cosine A, cosine B plus sine A, sine B. Now we found cosine A to be negative root 5/3. Cosine B was given to us as negative 1/4. Sine A was given to us as 2/3. Sine B we found was root 15/4. The two negatives give you a positive, so root 5/12 plus 2 root 15/12. So you can now combine these into root 5 plus 2 root 15/12. So that's our answer for cosine of A minus B. Let's look at problem 24. In which we have to find tangent of sine inverse of 1/2 minus cosine inverse of 1/2. Now, notice that both of the angles, sine inverse of 1/2 and cosine inverse of 1/2, are values of our special angle trigonometric functions. And we know that sine inverse of 1/2 is pi over 6 or 30 degrees, because sine 30 is 1/2. Also, cosine 60 is 1/2. So cosine inverse of 1/2 is 60 degrees. So this is tangent of negative 30 degrees. So tangent being a odd function, we can pull that negative out. So that's just negative tan 30. And that we know is tan 30 is root 3 over 3. So this is negative root 3 over 3. So that is our answer. Let's look at problem number 47. In which we have to prove that tan x plus pi over 4 is equal to tan x plus 1 over 1 minus tan x. So we start on the left side and use the sum identity for the tan function. So this is tan x plus tan pi over 4 over 1 minus tan x tan pi over 4. Just to recall, tan of a sum of two angles is this. Tan alpha plus beta is tan alpha plus tan beta over 1 minus tan alpha tan beta. So this is tan x. Tan pi over 4 we know is 1. And again, tan pi over 4 is 1 in the denominator, so that's just tan x. And that is what the right side is. So that completes our verification that indeed this identity is true. That is the end of this topic.